Like any star, it will run out of fuel in its core and it starts changing. It starts bloating and comes very close to Earth, and I'm terrified by this. On a clear winter's night, it's easy to spot the constellation Orion with the shield in one arm and the other extended into the sky. Orion stands out. Betelgeuse is a bright red dot marking Orion's shoulder and has intrigued sky watchers for a long time due to its unique dimming. Recently, Betelgeuse has become only 50% brighter than normal. Astronomers now understand that Betelgeuse is a shrinking red supergiant star, roughly 700 times larger in diameter than our Sun, which explains its changing brightness. Due to Betelgeuse's recent unusual behavior starting in 2019, some people have speculated that its dramatic end might be nearing. If Betelgeuse were to explode, it could be the closest supernova explosion in nearly 400 years, shining so brightly that it might be visible during the day. The cataclysmic explosion of this red supergiant is challenging much of what we understand about the cosmos. Is it conceivable that Betelgeuse has completed its life cycle? Could there be a supernova explosion visible from Earth? Let's find out. Orion stands out as a group of stars easily seen in the winter skies of the northern celestial hemisphere. It's one of the 88 modern constellations and was part of the 48 constellations noted by the 2nd century astronomer Ptolemy. Orion is bordered by Taurus to the northwest, Adonis to the southwest, Lepus to the south, Monoceros to the east, and Gemini to the northeast, covering 594 square degrees. Orion ranks 26th in size among the 88 constellations. Belgian astronomer Eugene Delport defined its boundaries in 1930 with a polygon of 26 sides. Orion is most visible in the evening sky from January to April, during winter in the northern hemisphere and summer in the southern hemisphere. Betelgeuse is the second brightest star in Orion, positioned in the upper right shoulder of Orion. During the winter, Betelgeuse is a magnificent ruby-red sparkling star that stands out with its regular pulsations. Despite its striking orange-red hue, a closer look reveals it as a roiling monster with a 4-day heartbeat. These stars, including Betelgeuse, are in their final life stages due to their massive size, making them the most numerous and widespread in the cosmos. As the second brightest star in Orion, after the blue supergiant Rigel, Betelgeuse is also known as Alpha Orionis. With its peculiar name and fluctuating nature, Betelgeuse is an unusual and interesting subject for astronomical research and observation. The exact distance of Betelgeuse from Earth isn't precisely known, but estimates vary between 430 to 724 light-years. Betelgeuse stands as the closest red supergiant star to Earth and the brightest among its kind. It boasts a radius approximately 764 times larger than our Sun. If Betelgeuse replaced the Sun in our solar system, its light would extend far beyond Jupiter and the asteroids, resulting in the complete engulfing of Earth, Mars, Venus, and Mercury. Every 10,000 years, Betelgeuse sheds the equivalent of one solar mass, expelling material in all directions, forming a nebula around the star. This nebula surrounding Betelgeuse is about 250 times larger than the star itself, spanning an estimated 30 astronomical units, or 30 times the distance between the Earth and the Sun. The star is likely in its later stages of helium fusion, a phase lasting tens or hundreds of thousands of years before culminating in a supernova explosion. Astronomers note that Betelgeuse is a variable star, experiencing cycles of brightness and dimming at regular intervals, typically every 400 days. Now, this pattern has been observed for over a century, with the star shining brightly, dimming to about half its peak brightness, and then brightening again. In December 2019, however, Betelgeuse took astronomers by surprise when it suddenly faded to a level 2.5 times fainter than its usual peak brightness. This significant dimming, known as the Great Dimming, saw the star lose 60% of its brightness in a matter of months. Some scientists speculated that Betelgeuse might be entering a pre-supernova phase, suggesting a different fate than the explosive death of a massive star in a supernova. The Hubble Space Telescope revealed that Betelgeuse temporarily obscured light from the universe due to the ejection of surface debris into space. While the Sun also has eruptions, Betelgeuse's were 400 billion times more massive than the Sun's coronal mass ejections, and its space debris likely had a mass greater than the Moon. Although Betelgeuse has returned to its usual brilliance, it's still not quite the same as it was before the Great Dimming. The star's 400-day brightness cycle has been halved to 200 days, and it seems to be getting brighter, exciting sky watchers. However, astronomers are cautious about supernova expectations. Morgan McLeod, a postdoctoral scholar in theoretical astrophysics at Harvard University and lead author of a recent paper on Betelgeuse, explains that our best models indicate Betelgeuse is in the stage of burning helium to carbon and oxygen in its core. If the models hold, it won't explode for tens of thousands or even 100,000 years. McLeod notes that a star's normal lifespan concludes when it runs out of hydrogen and begins helium fusion in its core. The red giant phase extends its lifespan beyond the helium-burning stage. Without helium, the star must convert carbon and oxygen into neon, magnesium, and ultimately silicon to survive. Over time, iron builds up at the star's core, and here's where things get interesting. Adding helium nuclei to an iron atom actually takes away energy from the atom instead of adding to it. So instead of a reaction that releases a lot of energy, the star's core starts absorbing it abruptly, leading to a type of supernova known as a core collapse supernova. While stars can live for billions of years during their hydrogen-burning phase, their lifespans progressively shorten during the rest of their lives. The helium-burning phase can stick around for hundreds of thousands of years, the subsequent stage lasts for a very long time, perhaps 10,000 years. The stage after that endures for thousands of years, the one after that for a century, and the stage just before the explosion lasts for only a few days or hours. If the massive star Betelgeuse were at the center of our solar system, it would extend as far as Jupiter. Astronomers can delve deeper into understanding Betelgeuse compared to other stars due to its size and its location in our galaxy, the Milky Way. Most stars, aside from the Sun, can't be thoroughly researched, they appear to us as mere isolated bright points. However, the Hubble Space Telescope and radio telescopes can provide detailed images of Betelgeuse because of its significant size. These images reveal a fascinating celestial body that differs significantly from our Sun. Betelgeuse isn't a uniform sphere of superheated plasma, instead, it's a collection of boiling gas bubbles, with the largest comparable to tiny stars. Massive plumes of hot material rise from Betelgeuse's interior to the surface, cool down, and eventually vanish, resembling the solar cycle but more robust. The star occasionally releases an enormous bubble, leading to significant dimming happening every few decades. However, this doesn't necessarily imply an imminent supernova. Even if astronomers' assumptions are correct, would we be able to detect if Betelgeuse were on the brink of exploding? While astronomers can analyze the chemical composition of Betelgeuse's atmosphere through advanced telescopes, they can't precisely observe its internal processes. Is helium still being used as fuel, or has it switched to carbon fusion? If the latter happened, how could we ever know? Observations of other red giant stars guide our understanding of Betelgeuse in the Milky Way. Unlike VY Canis Majoris, a red giant located 3,900 light-years away in the constellation Canis Major, Betelgeuse is believed to be considerably farther from its end. Over the past century, Betelgeuse has consistently brightened, in contrast to VY Canis Majoris, which has steadily dimmed. A century ago, VY Canis Majoris was visible to the naked eye, but now, due to significant matter emission, it's observable only in the infrared spectrum. This outflow is seen as the star moves towards its impending supernova explosion. Betelgeuse still retains 95% of its original mass, while VY Canis Majoris has lost nearly 60%. Poets once described Betelgeuse as a yellow star until about 200 years ago. Nowadays, it's commonly referred to as red. This could suggest that Betelgeuse is still in its early stages as a red giant. What would it look like from Earth if it goes supernova? Observations from the nearest known star explosion, supernova 1987A, have enhanced accuracy, but the exact unfolding of the explosion remains uncertain. While Earth's living creatures won't be harmed, the event is bound to attract attention. After Betelgeuse explodes, the sky will be lit for over 3 months by a star as bright as the half-moon, 9 times dimmer than the full moon. The focal point of this illumination would be a single extremely bright star visible throughout the day, casting shadows at night. Due to its widespread visibility, it would capture people's interests worldwide for about 2 months. The supernova would shine so brightly that one could read a book in its light if city lights were turned off and there were no clouds in the sky. If a supernova occurred, it would be visible during the day for about a year to humans. Even after its remnants fade, it would still be visible at night for years. Over the next few months, the supernova would gradually dim. When it finally vanishes, the left shoulder of Orion would be gone. After many years, the blown-apart outer shell of the dead star would drift far enough away to look like a planetary nebula or a ring around the faint core of the dead star. By that time, the star is expected to become either a neutron star or a black hole. The amount of the star that survives after a supernova explosion will determine its ultimate fate. The stellar explosion isn't a cause for concern. Some estimates place the minimum distance between Earth and the supernova causing it at a few dozen light-years. Recent research indicates Betelgeuse is about 724 light-years away, well beyond the danger zone. However, the explosion might still have unforeseen effects on our planet. Many species depend on the moon for orientation and get confused when faced with artificial light sources. The presence of a second moon-like object could lead to interference, making it challenging for astronomers to observe the night sky without disturbing local creatures. Even when the moon is already bright, astronomical observations become difficult. There might be a period without nighttime. Studying Betelgeuse comes with its own challenges. The brightness of the light could render equipment useless. Astronomers assure us that we'll receive ample notice if, against all odds, Betelgeuse explodes during our lifetimes. Instruments on Earth could detect neutrinos or gravitational waves emitted by the explosion a day beforehand. Factors influencing Betelgeuse's brightness could be numerous, with some astronomers proposing various dimming mechanisms at play in the later stages of their lives. Red supergiant stars expand, forming envelopes of gas and dust as their nuclear fuel depletes, and this expansion correlates with an increase in the star's luminosity. Stars like Betelgeuse can change in brightness in various ways. Red supergiant stars, similar to our Sun, have large convective cells on their surfaces, where internal turbulence pushes hot material to the surface. Once at the surface, some of this material explosively shoots into space like a massive radioactive burp, temporarily altering the star's brightness. Alternatively, this material might be blocking the star, making it appear less bright. Regardless of the cause, studying this unusual behavior can provide insights into the final stages of red supergiant stars. And everyone can observe it. Astronomers have a unique chance to observe Betelgeuse's last moments of nuclear burning before it explodes. The Kepler supernova, or SN 1604, was the most recent supernova explosion discovered in our galaxy. Named after the astronomer Johannes Kepler, who first wrote about it in his book, De Stella Nova, historical records indicate that the supernova was visible throughout the day for more than 3 weeks. Even though it's 30 times further from Earth than Betelgeuse, supernova 1987A occurred a few decades ago and could be seen with the naked eye for a brief period. However, ancient astronomers also observed several of these guest stars. Chinese astronomers noted a mysterious guest star around the year 185 AD, visible for an extraordinary 8 months, marking the first recorded sighting of a supernova by ancient sky watchers. There is some evidence that Roman astronomers observed it too. Astronomers have recently discovered the remnants of this dead star. Their research indicates that supernova RCW-86 happened when a companion star transferred much of its mass to a white dwarf, essentially a dead star. This caused an explosion about 8,000 light-years from Earth. Classified by scientists as a Type Ia supernova, the G347.3-0.5 supernova of 393 AD lit up the night sky for months, shining as brightly as Jupiter. According to astronomer estimates, the year 6 AD stands out as an exceptional time for stargazing in human history. If amateur astronomers had a time machine, they would have witnessed a spectacular guest star in the constellation Lepus. NASA states that SN 1604 would have been 16 times brighter than Venus, typically one of the brightest objects in Earth's night sky after the Moon. Eventually, it became so bright that it could be seen during the day, with an estimated visual magnitude of -7.5. The news of this extraordinary event would have quickly spread worldwide, with records from China, Japan, Iraq, Egypt, Europe, and possibly even North America documenting the occurrence. White Tanks Regional Park in Arizona features ancient rock art that some scientists believe might foreshadow the arrival of this new star. On July 4, 1054 AD, a new star burst forth in the constellation Taurus the Bull, captivating the entire planet with celestial fireworks over a 2-year period. Initially outshining the Moon, the supernova gradually faded away, likely catching the attention of many ancient civilizations. Petroglyphs in Chaco Canyon National Park and neighboring areas in New Mexico are among the intriguing potential records of this event, although some scholars have raised doubts about whether this rock art truly represents the supernova. The remnant, now known as the Crab Nebula, is a frequent observation for amateur astronomers. Scientists attribute its formation to the explosion of a massive star, categorized as a Type II supernova. Supernova 3C58, believed to have been observed by astronomers in China and Japan in 1181 AD, is another instance recorded as a guest star in historical accounts. Modern imaging of the supernova, including the image above captured by NASA's Chandra X-ray Observatory, has unveiled incredible new details about the remnants of the star's explosion. The pulsar at the center of this star, a fast-spinning neutron star, is surrounded by a dense ring. Even now, the X-ray jets of this extremely magnetic dead star extend for billions of miles, twisting and turning around the pulsar. In 1572 AD, SN1 1572 illuminated the sky as a new star in the constellation Cassiopeia. Before the telescope's invention, Danish astronomer Tycho Brahe observed it during his monumental project to chart and measure the heavens. Brahe concluded that the new star was beyond the Moon, a significant finding during a time of shifting perspectives following Nicholas Copernicus's ideas challenging Earth's centrality in the cosmos. NASA emphasizes the importance of this discovery. The supernova in question, Kepler's supernova, is named after astronomer and mathematician Johannes Kepler, who closely monitored it for over a year after it became visible in Earth's night sky. The supernova was even visible during the daytime, making it observable worldwide, including in China. Astronomers continue to study this remarkable supernova remnant today. Hence, another stellar explosion might occur before Betelgeuse, lighting up Earth's sky. Even though the latter event could take hundreds of thousands of years, the cosmos is filled with celestial events, each telling a unique story that captures the imagination of astronomers and stargazers. As we explore space, we come across remnants of exploding stars like time capsules preserving the drama of their final moments. Among these cosmic tales, the supernova SN 2011-1994D stands out. Found in the outskirts of the galaxy NGC 4526, this stellar explosion happened about 50 million light-years away from Earth in 1994. Earth observers witnessed the luminous display of SN 2011-1994D, an impressive performance that outshone its host galaxy. As the light from this distant explosion reached us, astronomers carefully studied the event, uncovering layers of cosmic history. The remnants of SN 2011-1994D offered valuable insights into supernova dynamics, aiding scientists in refining their understanding of stellar life cycles and the elements created in these cosmic processes. Meanwhile, the universe continued its cosmic activities, showcasing new celestial performances. In 2011, astronomers observed the emergence of another supernova named PTF11KX. This stellar explosion, situated in the galaxy M11, created a transient masterpiece in the night sky. The light from PTF-11KX traveled through space, reaching Earth and prompting scientists to interpret its cosmic message. Advancements in technology and improved cosmic observation provide a clearer unfolding of the celestial narrative. We stand on the verge of new discoveries, eagerly awaiting the next chapter in the language of the cosmos. Each supernova, a brilliant punctuation mark in the cosmic story, contributes to our evolving comprehension of the universe's vast tapestry. As we gaze into the night sky, we remain connected to the ongoing saga of stars, where each twinkle echoes a celestial event, a testament to the ever-unfolding drama of the cosmos. Beyond the cosmic ballet of supernova, our pursuit of astronomical revelations continues. Recent breakthroughs include the detection of gravitational waves, ripples in spacetime generated by cataclysmic events like the collision of neutron stars. These discoveries ushered in a new era of multi-messenger astronomy, where observations span the electromagnetic spectrum and gravitational wave signals. Advanced observatories like LIGO and Virgo have opened a unique window into the cosmos, allowing scientists to unravel the secrets hidden in gravitational whispers. As our cosmic exploration persists, the universe presents mysteries waiting to be unveiled, inviting humanity to unravel the profound enigma of its celestial symphony. Thanks for watching this video. Please leave a comment and a thumbs up if you enjoyed it.